Hello everyone and welcome back to my channel. In today's video we are going to be talking about a FEA general procedure to be followed while solving a structural problem by using FEM. Finite Element Method is a numerical technique used to solve structural problem by dividing the structure into smaller subdomain. It is called finite element, and solving governing equation for each element. The general steps involved in solving structural problem using FEM are as follows. Problem definition: define the geometry of the structure and specify the material property and boundary condition and loading conditions. Discretization: it is a divide the structure into a finite number of smaller elements using meshing technique. The shape and size of the element depends on the complexity of the structures and the accuracy required. Formulation of the element equation: the governing equation for each element are formulated using the principle of virtual work. This involves the selection of an appropriate displacement field, state displacement relation, and constitute relation. Assembly of finite element equation: the element equation are assembled to form the global stiffness matrix and the load vector for the entire structure. Application of the boundary conditions: the boundary conditions are applied to the global stiffness matrix and load vectors to obtain reduced system of equation. Solution of equation: the reduced system of equation is solved to obtain the nodal displacement, which represent the deformation of the structure under the specified load conditions. Post processing: the stress and strain in each element are calculated from the nodal displacement and used to evaluate the safety and performance of the structures. Validation: the accuracy of the FEM solution is verified by comparing the result with the analytical solution of experimental data. Optimization: the model can be used to optimize the design of structure by varying the material property, geometry, and the boundary condition to improve the performance and reduce the cost. The following the central steps: FEA can provide the powerful and efficient tool for analyzing and design structure in wide range of application. In conclusion, of the finite element is a numerical technique used to solve the structural problem by dividing the structure into smaller subdomain. It is called finite element. Solving the governing equation of each element. The FEM solution is involves series of steps including discretization, selection of the element types, choice of the displacement function, definition of the strain and displacement, stress strain relationship, driving the element stiffness matrix and equation, assembly of the element equation, solving for unknown degree of freedom or generalized displacement, calculating the element strain and stress, and interpreting the result.